Next is a man who needs no introduction, so I'll introduce him, Szabolcs Csepregi. He's the Director of the Search Technologies and the Markush technology at ChemAxon. He's going to give us a talk here about Markush, and particularly the Markush DARC file format. And just to check if I'm doing right, he comes from France, is that right?
Thank you for the introduction, Tim. Today I'm going to talk about our Markush project. Okay, so what are the Markush structures and how can we get those Markush structures we want to work with, and actually how can we work with them? And then I will show what we can do with Markush structures and what are our further plans for development. So what are these Markush structures? Markush structures are generic notations to describe classes of compounds. They are used in two main areas. The one area is the combinatorial chemistry domain, and the other area is chemical patents. And our Markush project has started 4 years ago, when a lot of customers approached us whether we can handle generic structures. And at that time, we couldn't, so we started working on this project. Now we have reached this stage where we can handle the following generic features. We can handle R groups, like the one here. We supply the definitions of these R groups like this on the depiction. R groups can be embedded into each other, so you can see that R1 here refers to R2, which is further defined here. We have atom lists, like here at this position there can be a carbon, oxygen, or nitrogen. We have bond lists as well, like here. It means that it is either a single or a double bond. We have a position variation bond, which is like this one. This bond can attach to either of these two positions. We also have link nodes, like this one. It means that it may be a longer chain. This carbon CH2 atom can repeat 1 to 3 times. The repeating units are a generalization of these link atoms, link nodes. This is a larger group which can repeat two times or 4 to 6 times. And the connectivity is HT, which is head to tail, which means that the next unit which repeats connects, the head of the next unit connects to the end of the tail of the other unit. And we have these homology groups, which very often occur in patent documents to describe classes of compounds based on functional groups. So this means the alkyl, aryl, and so on, these kind of chemical classes. So the goal of our Markush project was first, to be able to register Markush structures into our JChem database and to be able to search them in some way or other, and also to enumerate the Markush structures which are described by these generic structures. And we have encountered a few problems quite at the beginning. Well, the first problem was that the practical examples, especially those found in patents, were very complex. And it was not possible to do a full enumeration of these very complex Markush structures. So we had to find alternative ways to do that. And indeed, from the literature, we have known this problem because John Barnard had talked a lot about these problems. And the other complication was that the molecular formats which are widely available cannot really handle these generic features. So we had to add many extensions to our chemical representations to be able to at least represent and then show these features. So we have added many new features, for example, into our Marvin file format and the Marvin sketcher and then the JChem class library. And just this year, we have reached a state where we can handle a file format, the Markush DARC file format, which was designed to store patent Markush structures in an electronic form. I will talk about that in more detail later. So where can these Markush structures come from? Now I just mentioned that we have worked a lot on Marvin Sketch to enhance its capabilities. So Marvin Sketch is able to, you can use Marvin Sketch to draw these structures. It contains many nice features to help the drawing and handling of these Markush structures. For example, here is the menu item to draw a position variation bond. We have nice zooming controls to zoom to specific parts of Markush structures and so on. And this is the template which contains the template group which contains our default homology groups. Okay, the Markush DARC format is also available from this year. And in this format, we can now open Markush structures. And Thomson Reuters has a nice database of Markush structures curated from patents. And on this screenshot, you can see Marvin Sketch showing a part of a Markush DARC record. Okay. In the domain of combinatorial chemistry, there are other ways to assemble Markush structures as well. So sometimes someone wants to work with a concrete scaffold and has a list of reagents he wants to use to define the R groups. And in that case, the reactor tool can be used to actually remove the reagent groups from these reagents, the reacting groups, and put an attachment point there, which is needed for the description of Markush structures. And then the mole convert tool can be used to convert these reagents with the attachment points specified into R group definitions. And then at the end, we add the scaffold, and we've got the full Markush structure. Another way is to not to start from reagent files, but from ready molecules from a chemical library. We can do an R group decomposition. Again, we start off with a known scaffold. We specify the positions we want to put the ligands on. And first, we build up an R table. And we can turn this R table into a Markush structure. And we have just seen this morning that Infocom was very fast to take on this new feature, and they have integrated this feature into 9, and it is available there as well. Now we've got the Markush structures. What can we do with them? First of all, we have this Markush enumeration plugin, which is integrated into, for example, Marvin Sketch, but also into Instant JChem and the cartridge and so on. And with this enumeration tool, we can do full enumeration of Markush structures, or we can select special parts. And for very complex Markush structures, it's rather more straightforward or viable to do a random enumeration to get sampling of the vast chemical space described by the Markush structure. We can also calculate the library size. Whatever large this library is, we can tell by the very number how large it is. During the enumeration, we can do alignment of the enumerated structures so that we can refer back to the original Markush structure easily. And we can also color the scaffold and the different R groups with different colors. As I mentioned at the goals, we can now also register Markush structures into JChem, into the JChem tables. and we can search them. We provide substructure and full structure search in these databases, and during this process, we do not do any enumeration. And actually, during the searching, we do the translation of these homology groups. So these alkyl and so on, these generic terms can be searched for by specific molecules. I will show examples of it later at the demonstration. And to better visualize the substructure hits, it is first of all, it is possible to show the substructure hits on the original Markush structure. And here you can see an example. We've got a query structure and the Markush we want to search it in. And you can see the highlighting that this query maps into different parts of the Markush structure. Now it is not very easy to see what's going on here, which part comes from where. So we have introduced a new technique to show these substructure results, so that those parts of the Markush structures which overlap with the hit, we expand those variables. And in that case, we have another Markush structure, which is in complexity, it's reduced. And it contains the query structure as one whole unit. In this way, it is much easier to see where we have found the substructure. When a substructure matches into the Markush structures in different ways, it may be possible that we have multiple reduced Markush structures here. Okay, what's new? The handling of the Markush DARC file format is new. We just introduced it in 5.3. And it brought a lot of improvements because it contained many features which were not available before. One of the most prominent improvement was that now we can handle R groups with more than 2 attachment points. Currently, we use a temporary representation using data as groups, but we also plan a proper representation of attachment points in Marvin. That will help us. That will help us to create these multiple attachment points more easily. It's okay now. This temporary solution is okay when we want to work with Markush DARC files, because those already contains all these attachment points. But if we want to draw them by hand, it's not that straightforward using the current way. We also worked on the homology group definitions so that they match exactly how Thomson Reuters meant to mean these homology groups. So we have did some minor adjustments in the semantics of these homology groups. And in instant JChem, we have added a batch converter so that many individual Markush DARC files could be merged into one batch file and loaded in batch. And I think Tim Dudgeon is going to talk about that in the afternoon. Okay. Another improvement was that for the enumeration, we provide an example set for the homology groups. And we just replaced this example set with a much higher quality example set. And we have obtained this example set, in this case, by automatic statistical analysis of a large chemical database. OK, let me show you a demo now. I have a video. So this is instant JChem, if you don't know it. And we've got a Markush table here. By default, we only show the scaffolds so that it's easy to see. But we can switch on the R group definitions as well, if we are interested. But in this case, the display is not so easy to grasp. Okay, let's do an enumeration. First of all, a full enumeration of structures. Well, this is the first 100 structure. Let us just copy one of the enumerated structures to the clipboard and go to the query panel. Okay, we have let's do a substructure search now. We have found one record which contains this substructure. Let's do with where this substructure is located. Okay, we can see the highlights. And now let's see the Markush reduction. Now we are back to the enumeration dialog. This shows the reduced structures. So we have found this substructure actually in 2 places. Okay, let's go back to the query panel and let's just clear this substructure and copy the previously, we paste the previously copied structure and switch to full structure search, which means that we are searching for a Markush record which has that structure as a full enumerate. And indeed, we have found that Markush record which we copied it from. So let's just delete a few parts of this Markush structure, of this enumerated structure, and do a substructure search in this time and see, yeah, we just meshed a part of the Markush structure in this case. And let's see a Markush reduction. And indeed, this substructure has been found in many different places in the Markush structure. Okay. Now we are switching over to Marvin Sketch and do some advanced Markush enumeration. First of all, see the library size. It's a 10 to the 9th Markush library. We can do some sequential enumeration. First without enumerating the homology groups. Okay. While we are seeing the results, the calculation went on. Okay, let's enumerate the homology groups as well. Now this version, which is shows, it still uses the old definitions, not the ones coming from the libraries. Oh, by the way, those definitions are customizable, so it is possible to put your own definitions for hetero, real, and so on. Okay, let's do a random enumeration. No, in this case, we just select part of the Markush structure and only expand those variables. Okay, and actually we can navigate this way in the Markush space, select another feature, and dive down into the Markush space in more detail, and so on. Okay, let's see the zooming scaffold, zooming to the scaffold. Now we are selecting the homology groups and expand those. Okay, I think that's okay for now. And I will stop this one and switch over to Instant JChem, which contains, yeah, okay, this Markush table now contains some structures from the Thomson Reuters dataset. These are these Markush DARC files. And these are very, very, very complex structures, as you can see here. Actually, we had a feeling that these patent Markush structures are rather obscured to prevent all the competitors to actually see what's going on in the invention. So let's just select one Markush structure and again, let's do some enumeration here. And I just copy this structure and run a substructure search. Okay, so we've got this structure, this Markush record. Okay. And as a substructure, we have found this one at several places. And actually, the Markush was formulated in a way that this enumerated structure is contained as a substructure in other places as well. Okay. And we can see here that some of these homology groups, let me just, these homology groups, in this case, the homology groups are represented by these three-letter abbreviations. This is the Markush DARC representation for them, and we just treat them as aliases to the more representative, longer names. And you can see that this translation was working fine. That CHK is actually the alkyl group, and hal is the halogen atom, and so on. Okay. Now, and this database was loaded by Tim Dudgeon, and he's going to talk about in the afternoon how he created this database and how he added additional data coming from the patents. So the main use cases for this technique is to search when you do an online search for patents, you can grab those records which match and help these techniques with refining the results and visualize them and so on. If you also have some selected patents, you can do white space analysis or patent busting around the chemical space, which is represented by those Markush structure. It can be helpful in curating Markush structures, especially those pieces which were mentioned at the combinatorial chemistry domain, and an in-house storage of a small Markush database. We have many things planned. I won't have time to talk about all these in detail. The major areas are further improvements in the Markush DARC representation. There are a few things we are working on at the moment. We want to handle also some exemplified structures in the patents, and we have further plans, longer-term plans, for example, the overlap analysis of Markush structures, and in the Markush formats domain, we are part of a UPAC committee to create a Markush standard for as an extension of the Inchi format, and this committee is headed by Niko Goncharov, and Thomson Reuters is also part of the committee, so we are working together with them on this format. As a summary, you could see that now we can handle, store, search, and enumerate patent Markush structures. And we also have compatible patent database provided by Thomson Reuters. And we are not standing still. We have lots of plans and improvements to add to this project. I would like to thank my colleagues who have helped in the development, especially Nora and Robert has made a large contribution, especially during the last year, by adding all these features for the Markush DARC format. Tamás and Ali have worked on the enumeration part a lot, and Tamás, Szilárd, and the team has worked on the database side, and Chizi helped a lot in the concepts. And I would like to thank the people at Thomson Reuters, headed by Tim Miller, but also Steve Hajkowski and Jez and Linda helped a lot us with these Markush DARC files. And many of the early adopters have given us feedback how to improve the tools, what to expect. I would like to thank them, and some of them are present here. I would like to thank you for your feedbacks. And if you are interested, tomorrow we are holding a Markush forum, and we will talk about all these in more detail there. Thank you for your attention.
Okay, thanks, Szabolcs. As you mentioned, there's the Markush forum tomorrow, which is probably the best time to ask questions. So while Tim is getting set up for the next talk, if there are any very quick questions, Wendy again. If there are any quick questions, then maybe ask.
You said it might be used for a small in-house Markush database.
Mm-hmm.
If you are doing compact storage of the Markush structure, why can it only be small? Or why did you say small?
For several reasons. Well, these Markush structures are usually very, very complex.
Yeah, sure.
And it takes some time to search them. And we currently don't have much of a screening in this. So we rather recommend this technique at the current state to handle several hundred Markush records.
You've answered it's not the storage space, it's the search complexity.
Yeah, basically, yeah.
Okay, one final question. I asked the question and the answer to be brief.
Okay. Have you considered any kind of approach for trying to estimate the size of overlap between two Markush schemas in terms of the size of the chemical intersection between the chemical space?
It is in the longer term goals. Some of the variability can be used in the query side currently, but not all Markush features are handled.